Okay, so today we look at the probability. In probability, there are some terms that you have to know before we proceed to the idea of what probability is. All right. So in probability, all right. So we'll first look at the term experiment. So in experiment, all right. So there is the the definition that you have to memorize. So that is something on in the book, but you can read on your own. But now I'm gonna explain. I'm giving an example. Like experiment. Let's say we are going to roll a dice. All right. We have a dice and we're gonna roll dice dadu. Okay, kita nak baling dadu. Alright, so that is the experiment, rolling a dice. So the outcome, alright, is actually, alright, when you roll a dice, okay, you can get 1, alright, you can get 2. So this is actually known as outcomes. Alright, so sample space is actually the list of all possible outcomes, meaning to say that we're gonna have for this rolling experiment of rolling dice, we'll get 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. So these are all the possible outcomes of rolling a dice. So this is actually the sample space, which is the list of all possible outcomes. Where in an event is actually, let's say we're going to find the probability of getting odd number, meaning to say that we're going to have a 1, 2, and 3. So this is the event that we create. We create the event, all right? So we can find the probability, right? So these are the 4 terms that are very important in probability, right? So the basic idea, let's first look at the basic idea of what probability is. All right, let's say we have a class. In the class, we have 10 boys and also 15 girls. When selecting, we want to select a student randomly, all right? So from the list name, what is the probability that we are going to select a boy, okay? So we look at, so to select a boy, so usually we'll have to write the probability of selecting a boy, PB, is given by, right? So you will first write the number of boys, which is 10 over, so 10 plus 15, which is the total number of students. So in this case, you'll get 10 over 25, which is 2 over 5, okay, or 0.4. And what about the possibility? Okay, that is the probability, all right? So the value should be between 0 and 1, all right? If it is more than 1, so that is the probability, that's something else. So you have done something mistake in your calculation. All right, if we want to find the probability of getting a girl, so we're gonna have 15 over 10 over 15. So we'll have 15 over 25, which is given by 3 over 5. So this will be 0.6. So the probability of getting a girl from the list name, which is selected randomly, will be 0.6. Okay. So why the probability is higher? Because the number of girls is higher. It's more than the number of boys. Okay. That's the basic idea of what probability is. Okay. So another term that you have to know is actually the sampling with replacement and also sampling without replacement. All right. If it is something with replacement, okay. So let's say in this experiment, we will have to find the probability of getting round 1. Okay, we're gonna pick randomly a red ball from these 5 balls, which has 3 red balls and also 2 blue balls. So the probability of getting red ball is actually 3 over 5, because the total number of balls is actually 5 and the number of red balls is 3. So the probability from round 1 is actually 3 over 5. Why 3? Because we have 3 red balls. Right? So now 1 red ball is already being selected. Okay, 1 red ball is already being selected. But because it is with replacement, to go to round 2, meaning to say that we're gonna put back the ball. Right? So for round 2, the probability of getting a red ball is still 3 over 5, because we already replaced the ball that we have taken, but we put it back. Okay, that is the meaning of sampling with replacement. But for sampling without replacement, all right, for round 1, of course we'll have 3 red balls over total balls is 5. But because it is without replacement, so this ball is already taken out and it is not being replaced. So now for round 2, the probability of getting the red balls is actually 2 over 4. Okay, so the number of balls is already decreasing. Okay, so this is the difference between the sampling with replacement and also sampling without replacement. Okay, so let's have a look at the example 6.1. All right, medical researchers list the possible gender, male or female, of the first 3 babies to be born to a laboratory animal by order of birth. Alright, so list all the sample space. Okay, so we don't know whether the first baby will be male or female. Alright, so we can list all the possible outcomes, which is the sample space. So we put it in the set form. Alright, so when we put in set form, okay, so the sample space is usually labeled by S. Alright, so okay, let's say we have all males. Okay, so male, second baby is male, and the third baby is male. Right, so we have another outcome. Let's say the possibility of getting this female. Okay, let's say we have male, female, male. Okay, or female, male and male. Okay, all right, so that's the probability of getting two males. All right, what about if getting one male? All right, so if you have male, female, female, it can be female, male, female, and another one is actually female, female, and male. And the last part is actually not getting a male at all, so meaning to say we have all male, all female, so F, F, F. So these are all the possible outcomes, so which is written as the sample space, which is the all possible outcomes sample space. Okay, so now we're gonna list an event A, which is in which A represents the event of obtaining 3 females. So from this, so actually we can actually put in set form. All right, so all 3 females, of course, only this one. Okay, let me highlight that one. So only this one. All right, so we'll have female, female, female. So this is the only possible outcome for event A. Okay, what about event B? So in event B, we have that for event B, we're gonna have the event of obtaining at least 2 males, meaning to say that at least 2 males. It doesn't matter whether the male is for the first baby or the second baby or the third baby. All right, but it must be 2 males. So we can highlight from this. Okay, let me use blue color for highlighters. We want to have at least 2 males. Okay, this is at least 2 males because we have 3 males. All right, at least it can be more than 2 males. Okay, at least 2 males, at least 2 males, at least 2 males. This one only 1 male, but it is not at least 2 males, so less than 2, so it's not. So that the one that being highlighted in blue color is actually the event B. So it can be male, male, male. It can be male, male, female. It can be male, female, and male. Another one is actually female, male, and male. So these are all the possible outcomes for the event B, which is getting the at least 2 males from the event. All right. Okay. So let's now move to the concept of Venn diagram. All right. So in a Venn diagram, we have the universal set, meaning that the collection of all sets. All right. So this is called universal sets, labeled by that symbol. I don't know what it's called. All right. So let's say if we have a set A. All right. This is the set A. So the complement of A will be labeled by A prime, which is outside A. All right. Meaning to say that everything inside this. All right. As long as it is not A. All right. So the complement of A is actually everything except A. That's the meaning of complement. All right. So everything outside A. So as long as it is outside that set A, so it will be the complement of A. So that is A prime, which is the complements of A. Complement, all right, pelengkap. Okay, the rest that is not A. Okay, so the next one will have the intersection. Intersection is actually what do we call that? Persilangan. So where does A and B intersect? Is of course in this area. So this is labeled by intersection. So A intersect B. So labeled by this symbol. A intersect with B. Okay. A intersect with B. All right. So now we'll have the union of A and B. So the union of A and B is actually when A combines with B. So they combines all together. So it will become the whole thing where A combines with B. So they will become one. All right. So something like this. So this is actually union. So this is labeled by A union with B. So union symbol U. Okay, A union with B. Where if A and B are mutually exclusive, so please take note the words mutually exclusive. So that means there is no intersection between A and B. Meaning to say when we have A intersect with B, so it will be a null set. Meaning that it has no element inside it. There is nothing inside it. Okay, all right. So that is the concept of Venn diagram that will be used a lot. Okay, all right. So let's move to example 6.2. Okay. In example 6.2, a researcher conducted a survey to find out where people purchase their electrical appliances. Out of 110 randomly selected respondents, so we have a total elements is actually 110. So 70 would say that they purchase exclusively at local mall. Exclusively meaning to say that they only buy at a local mall. Okay, right? They only buy at local mall. And then 30 said that they purchase exclusively. So the word exclusively at electrical shop. Okay, so meaning that the 30 of the respondents buy the electrical appliances at the electrical shop only. Okay, but not at the local mall. Okay, and 10 of them said that. 10 of them. 10 of them said that they both shop at both, okay, local mall and also electrical shop. So we can start drawing the the set. So let's say we have this one. Okay, let me draw bigger. Okay, this looks better. Okay, Okay, let's say 70, say at local mall. So let's say I level as LM. So I'll put 70 here because they only shop at the local mall. So it's not inside this, okay? And then we'll have 30 said exclusively at electrical shop. So electrical shop. So it will be 30. So, and 10 of them will be at both. So at both is actually here. So when you add this up, so 70 plus with 10 plus with 30, so you will get back 110. So that's it. The 110 total, what do you call it? Total respondents. Okay, so that's how you draw a Venn diagram. Okay, very simple. Right, so now example 6.3. A hospital record shows that 12% of patients are admitted for lung treatments. All right, so this one is for lung treatments, and 16% for heart treatment. So I'll put this as H heart treatment, and 2% for both lungs and heart. So meaning that lungs and heart, so it intersects there. Okay, so when it's given as okay, another point that is very important, you don't put a dot because this is not element. Okay, don't put that. This is a number, represents the number of people. Same goes to this because it is given in percentage, so you have to convert to decimal. How do you convert to decimal? You have to divide with 100. Okay, so to draw this, okay, so let's say you have this one and also this one. Okay, this is lung and this is heart. Okay, so for lung only 12%. Okay, for lung only 12%, but you better put this one first. Okay, you better put for the intersection, which is 2%. So 2 is actually 0.02. Okay, that one is for 2%. Okay, so if it is 12% for lung treatments, okay, so the whole thing here, this is the lung treatments, meaning that the whole thing here. Okay, the whole thing here. Okay, but now we only want for only lung, meaning to say we have to subtract the for the intersection, which is 0.02. So for lung it's actually, all right, so 0.12, which is 12%. So you have to subtract 0.02. So you'll get 0.10. So actually 0.10 here. Okay. 0.10. That one is for lung. Okay, and then for heart, okay, actually for heart, the whole thing here, if it is 0.16 the whole thing, so what about only for this part? Okay, for that part only. So what we need to do is that we have to subtract 0.2 from 0.16. So for heart, you have to subtract 0.16 with 0.02. So the rest will be 0.14. So will be 0.14. If you don't believe me, and then you have to add. For heart, you have to add this 2. So you get 0.16. And for lung, you have to add this 2. So it will be 0.12. Okay. So that's how you calculate the percentage for this one. So we know that in universal set, meaning to say that the probability will be 1. Okay. So in this case, to get the rest of this probability will be the rest of the number. So will be 1 minus 0.10 minus 0.02 and then minus 0.14. And then when you press your calculator, okay, 1 minus 0.1 minus 0.02, okay, and then minus 0.14 will be 0.74. This 0.74 means to say it will be here 0.74. If you add them all together, so it will be 1. So the probability for the universal set should be 1. Okay, bear in mind. Alright, so that's how you calculate. So you have to subtract the one that is the intersection. Alright, always do that. Okay, you always do that. So another method of doing the listing the possible outcomes for probability will be using the tree diagram. So it will be easy, I think. Okay, so let's treat this kind of question. Let's say we have a bag which contains of 5 red balls. Okay, 5 red balls and also 2 blue balls. 3 balls will be drawn one by one, meaning that we'll draw a ball and then we stop, and then we'll draw a next ball and then we stop. So it depends on the situation. If it is with replacement, meaning that if we draw the ball and then we get the ball, okay, we note the color and we put it back the ball, and then we'll try to draw the ball and we get another color, or if the same ball, the same color, it will be okay. So just note that. Okay, so that's the meaning with replacement. We mean that when take the ball and we put it out and then we put it back. Okay, right. So what will be the outcome of getting at least 2 balls selected? Okay, at least 2 balls selected. 2 balls. I think 2 balls. 2 blue balls. Okay, 2 blue balls. Okay, the color is missing there. Okay, so let's try drawing the please take note that we have 5 red balls and also 2 blue balls. Okay, so for round 1 will be, okay, so the possibility will be, okay, so the color will be red and then blue. This is for round number 1. Okay, first drawn. Okay, so it can be red, it can be blue. So now okay, this is for round 1. So now we have 4 red balls and also 1 oh sorry, oh we cannot do this, okay, sorry. Okay, please take note that. Okay, all right, so for round 2 we try to take the ball. All right, so it can be red or it can be blue. Okay, same goes to this one, it can be red or it can be blue. Okay, so because we want to take 3 balls, which is round by round, so round 3, so we try to draw another ball. Okay, take another ball. So this will be, okay, it can be red or it can be blue. Okay, this one also it can be red or it can be blue. Okay, still we have 2 blue balls. Okay, still okay lah. All right, so now sorry for that one. Okay, so next one will be blue red. Okay, it can be red or it can be blue, but for this one it can be red. And can it be blue? It can, because we replaced the balls. Okay, even 2 balls were were drawn, but we put it back the blue ball, so it can still be blue, the possibility there, right? Okay, so we can list out all the possible outcomes. So the first one will be red red red, and then we go red red blue, something like that. Okay, so we'll have red red blue. Next one, red blue red. Okay, so we'll have red blue red, so it has red blue blue. Okay, so this one will be blue, right, blue red red, and then we have blue red blue, and then we have blue blue red, and it can be blue blue blue. All right, hey, how come it can be 3 balls, 3 blue balls, but we only have 2 balls because we replaced the balls? So these are the possible outcomes for this experiment. But now we want to find the outcome of getting 2 blue balls. Okay, 2 blue balls, so we highlight all the possible outcomes for 2 blue balls, meaning to say that this one, all right, blue balls, there are 2. All right, so this one, also this one, because it says at least meaning that we can have 2 or more blue balls. Okay, so there are 4 outcomes there, right? That's how you do the tree diagram. All right, so you can calculate the probability, which is I think 4 over the whole thing will be 8. Okay, so 4 over 8, which is 1 over 2. All right, something like that. That's how you get. All right, so now without replacement, meaning that when we draw the ball, we don't put it back. Okay, all right, so we don't put it back. So what is the outcome of getting of the first ball blue? Okay, let's try. We try to draw the what do we call the tree diagram. Okay, so this one, make it bigger. Still, bear in mind that we have 5 red balls and 2 blue balls, and we don't replace the ball. Okay, the first one, okay, round number 1 will be red or blue. Okay, round number 2, still, okay, it can be red or it can be blue. All right, so if taken for the first round is blue, so the second round will be red or blue. Right, now we go to round number 3. Okay, we'll have something like this one red, this one blue, this one also red, this one also blue. Okay, can be there. This one can be red or blue, but this one, all right, so be careful for this one, because we already take out blue balls for the first round and the second round, so there are only 2 balls for blue color, and we don't put it back, so it cannot be blue there. It should be R here. Okay, it should be red color here. Okay, so it's different from the previous example here. Right, so now we have to list out all these possible outcomes. So it can be red, sorry, it can be red red red, red red blue, red blue red, and red blue blue. Okay, then we have a blue red red, a blue red blue, and then we have blue blue red, and then we have blue blue red also. Okay, all right, so now we are going to calculate the probability. What is the outcome? We're going to find the outcome of getting the first ball blue and the third ball red. So we want to find B and then R at the back. Okay, so this one doesn't matter, it's either B or R in the middle. Okay, so find the one that have B at the front. Okay, so and R at the back. So B at the front and R at the back, B at the front and R at the back. Okay, B at the front and R at the back. So B at the front. Okay, something like this, right? Okay, so we have 3, so 3 out of 8. Okay, 3 out of 8. 1, 2, 3. Yes, 3 out of 8. All right, so that's the probability if you want to calculate the probability. All right, so let's have a look at the next example. Right, example 6.6. A box contains colors coded sign. It can be 3 red color, okay, 3 red color, 4 yellow, and also 2 white. So we have this one. 2 signs were selected one after another without replacement. Please note that it is without replacement, meaning that one card is drawn and then it is not put back. Okay, what is the outcome that one yellow? Okay, we have to draw this. Okay, so for the first round it can be, all right, it can be 3, what do we call that, 3 outcomes, 3 possible outcomes: red, blue, red, yellow, white. Right, red, yellow, and white. Okay, that one is for the first round. So this one is round number 1. So let's move to round number 2. Okay, for round number 2, it can be red, still red, yeah, what do you call that? Okay, for round number 2, it can be red, yellow, or white. Okay, so this one will have red, yellow, and white. And also this one will be red, yellow, and white. So because there are only 2 rounds here, so we have the possibility will be for the possible outcomes red, yellow, red, white. Okay, it can also be yellow, red, yellow, yellow, and also yellow, white. And we have white, red, white, yellow, and then white, white. So right, so what is the outcomes of getting 1 yellow and 1 white? Okay, so 1 yellow and 1 white, meaning to say that 1 yellow and 1 white, we want yellow, white, or white, yellow. So you can find any of these, all right? Yellow, white, so, and white, yellow. So these are the outcomes, okay? All right. So if you want to calculate the probability, it will be 2 over, all these will have 2 over 9, all right? So that one's 2 over 9. So the outcome of getting at least 1 red sign, 1 red sign, 1 red sign, so it can be 1 red signs. Okay, so we have this, all right. I have to delete this one first. Okay, 1 red sign. So we mark all those with red signs. So we have 5 over 9. So that's how you draw the tree diagram for this equation. Very easy, right? Then using the tree diagram, we can also use the what do you call that, contingency table, which is also clearer to solve this probability problem. Alright, so we have Ace Sendam Berhad, alright, has recently conducted a survey to obtain a gender and age profile of customers. So 200 purchases were selected where, okay, I'm gonna write this, 80 were female purchases and 60 were males. Okay, so 80, this one is total. Oh, what happens to this one? This one is gender actually, this one is total. Okay, so 80 were males, 80 were females, and this one 80 females and 60 were males. Okay. Or males, sorry, this 60 means, okay, if 80 were females, so the rest of, okay, from 200, right, so let's draw this, from 200, so 80 were females, so of course the rest of it will be 120 were males, but from this 120 of males, 60 are under 30, okay, 60 are less than 30 years old, right, so, okay, 60 are less than 30 years old, okay, and then we have 50, I think this one is purchases, okay, 50 purchases are over 45, meaning that 50 purchases are over 45 for both males and females. So okay, so above 45, right, over 45, so meaning that we have total which is 50 here. Okay, I use blue color, so 50 are above 45, and 10 of them are females. From this 50 will be 10 of them will be female, so will be 10 years, of course will be 40 here. All right. Okay, so a total of 30 females. So 30 females are between 30 to 45. So 30 females. So 30 females are here. Right, so because the number of females, the total number of females should be 80, so you put it 80 here, so the rest should be here. Okay, so 80 minus 30 minus 10 will be 40. Alright, that's how you calculate. And the total number for males will be 120, and we know that for less than 30 years old will be 60 people, so this will be here. So to get this here, so 120 minus 60 minus 40, you get 20. Alright, so if you add all this, you add 60 plus 40, you get 100. This one 30 plus 30, you get 50, and the total number should be 200, which is the total number of purchases. Alright, so that's how you do the contingency table. Very easy. Alright, okay. So it's easy to find the probability here, right? If you want to find the probability of getting a male, it will be 120 over 200. If you want to find the probability of getting a male which is less than 30, so 60 over 200. And that's how you calculate, all right? All right, next one. Okay, let's try for the next one. The sales manager, all right? The sales manager of a computer shop recorded the sales of 250 units. So there are 250 units of computers in particular month. Of those 250, 180 units belong to model B. So model B would be 180. So the total number of model B 180. I put it there, right? Sorry, we should have the line here. Okay, 180, because the total number of computers would be 250, so I'll put it here, 250. So 250 minus with 180, so of course the total number of model A will be 70. Okay, that's how you calculate. To model B, of which 30 units were sold with 17 inches monitor for model B. So 30 unit with for model B, 30 unit with 17 inches, so will be 30 here. So the rest will be 150. Okay. Alright, so for model A, okay, 25 units of model A was sold with 17 inches. So 25 should be here. So the rest of it should be is 45, yes, 45 here. Okay, 45. Okay, so you try to add to 45 with 150, you get 195, and then 25 with 30, you get 55. So if you add them up together, you get 250. That's the total. Okay, all right. So it is very easy to fill up the contingency table. There is no problem for this one. So if you want to calculate the probability of getting, model A with 15 inches, so you get 45 over 250. But if you want to get the probability of getting a model A, so it will be 70 over 250, right? So same goes for model B and so on. That's how you do the probability using the contingency table.